I would like to thank you, Jonathan, for the great presentation. And if you stop sharing your screen, our next invited speaker is Mr. Scott Sklar. We are very happy to have him as our invited speaker, director of George Washington University Solar Institute and president of the Stella Group. So please, Mr. Sklar, please take it away.
Hey, thank you very much. Great to be here. I'm going to share my screen here.
Great.
All right, great. So thank you very much. I actually wear two hats. I teach 3 interdisciplinary courses on sustainable energy at George Washington University, but I'm actually energy director of the Environmental Energy Management Institute at GWU. And so we do a lot of work with state and local governments and international governments. And then I'm a head of a 20-year-old company called the Stella Group, where I'm an owner's rep. So I don't have any ties to companies or technology, but I'm a technology blender. And so I work with companies on microgrids and zero energy buildings and all that. And probably about a third of all the international disasters that go on, I get a call from whomever and saying, hey, we have a problem and we need different kinds of units to power this kind of activity on site. And so then I help them select the technologies, call the companies, and get things shipped on site. So I have a lot of experience on integrated deployable systems. And by the way, I have 2 buildings in North Arlington, 3 blocks from the Clarendon Metro stop, all self-powered, and a 2-story office building with solar photovoltaics, wind, and a hydrogen fuel cell, and a web-enabled battery bank, totally self-powered. And then my home, which has solar water heating, geothermal heat pump, and a huge multi-different panel photovoltaic system tied to an even huger, if that's a word, battery bank. So happy to give socially distanced tours anytime. So I do all the renewable technologies in my company: advanced batteries and controls, high value energy efficiency, fuel cells, geo exchange, which is geothermal heat pumps, heat engines, marine and micro hydropower, free flow, modular biomass, photovoltaics, small wind, solar thermal, and all the others. So a lot of operational and practical experience. So this just came out, United Nations World Meteorological Agency report. Weather-related disasters occurring each year is increasing. And so this is the AP news item on it. And so, as you know, we're seeing more intense weather patterns, many of which are climate induced. Plus, we have geological issues not tied to climate, like earthquakes. And then, of course, we have some of the other issues relating to climate, forest fires, and floods and sea surges. So we're seeing lots of that. First thing that goes down is grid. Second thing that goes down are cell towers. So this I just pulled out. This is 2014, but this is sort of where we see incidences of outages reported by sectors. Now, this is in the United States. So energy, with the electric grid, critical manufacturing issues, of course, are pretty large. Healthcare, 6% is pretty large. So these things, I don't know if many of you involved in when we had Hurricane Sandy hit the East Coast, but we had 5 hospitals with patients in operating rooms had to be moved during their operations because the diesel engines failed during the grid outages. So, and by the way, if I ever get murdered and you read in the newspaper, it's because I badmouth diesel engines all the time. They were great when you had no alternative. They're not the best option in this modern era. This is 2018, and looking at Illinois pressing for microgrid development. Now, a microgrid is usually a blend of technologies, generally focused around storage, so generally a battery bank. Not all, but many, most are. And then you have, in some cases, diesel or propane generation if you already have it there. Obviously, I integrate it if it's already there. Solar, very common. And then a whole range of others. I do small wind and biogas all the time. And so I generally try to do technologies that don't have a fuel train. What do I mean by fuel train? A fuel train means you have to bring the fuel in the area. Well, during an emergency, that's very hard. You can't bring fuel in the area. So that's where diesel and propane, frankly, have more of a problem, and why I like to use the on-site renewable resources. This is recent October 11th, and we're talking about 600,000 people lost power in Hurricane Laura in Louisiana. Not shocking, of course. Coastal Louisiana has been battered almost every year now with significant hurricane and flood damage. And so we're seeing more and more drives for net zero energy buildings, zero energy buildings, microgrids, and just hybrid power systems. So when I talk about infrastructure, I'm talking about communications, cell towers, government communications, even in buildings, area cameras, the first responders, police, fire, and emergency health support, pipelines for water, sewage, and fuels. In fact, when Katrina came in, I worked for Governor Barbour and also the New Orleans City Council, and you couldn't even, once you got even the wires back up, you couldn't start up the power plants unless you got water. I mean, that's how we make most of our electricity in the United States. So you need water, and you need water at pressure. So bringing up water pipeline pumps were very, very critical. And obviously, if you don't have your sewer pipeline pumps and your sewage treatment plants, your sewage starts backing up in the buildings. And no matter what you're doing, you have to get people out of the buildings. So there's a lot of coordinated issues. Transportation lighting during Katrina and Sandy were critical, because if your major intersection lights, signal lights don't work, you had your emergency responders, you had horrible traffic jams, and you couldn't move people, you couldn't move emergency folks around. So transportation lighting, both road and railroad, very, very critical, and including riverport and airport lighting. Data centers, obviously, for the internet, very critical. Data centers obviously have cascading backup diesels primarily, but we're finding again, if their diesels go down or you have a diesel malfunction, you got a lot of problems. So there's more and more. And of course, when you got road blockages and road washouts, you can't move diesel fuel around. So you got those issues. And so within buildings, you have Wi-Fi and phone. I do a lot of systems tied to what I'll call critical function circuit breaker boxes. So Wi-Fi phone security systems, obviously operating rooms in hospitals, data centers within buildings, sump pumps in the basement of the building so they don't flood out, get one elevator shaft working, and in very hot or cold climates, of course, some minimal working of the HVAC system at least. In communities, doing a lot of planning with my George Washington University hat on having communities select areas for hybrid power systems or microgrids that, let's say, strip malls that have ATM machines, some kind of 7-Eleven type of a store that has refrigeration for food. Some cases, certain drugstores have their own healthcare section for drugs. Very good idea. Small healthcare areas in strip malls, such as eye health and dental, so people aren't going to the to the hospitals in the emergency room, and let the emergency rooms go for major deal with the major cases. And of course, hospitals. Gasoline pump islands are very important. If you can't get gasoline, you can't move around, even for the first responders. And then what we did in Louisiana was school as convergent points. Displaced people, either instead of going like they did to the big arena, go to their local school, or convergence points for first responders to play out of. And again, we don't power the whole school. We power the office for the office machine, the phone, and the PA system, the computer lab, the gymnasiums, and the kitchen. So at least you have some operational functionality for food, for communications, and safety. The microgrid market's actually growing hugely, if that's another word. And so this is looking at 4.3 gigawatts or 4.3 nuclear power plants worth of generation capacity by the end of this year. And it's a great market. It's just booming all over the world. My phone rings off the hook, in fact. Um, this is a 2018 article on Global Telecom Network about 113.5 gigawatts of distributed generation energy storage between 2018 and 2027 by Navigant. And again, I do a lot of infrastructure work, and of course I teach the first specialized course on renewable energy and critical infrastructure in the US. But so we rely on cell towers so critically for both communications and the internet that we have to back them up with absolutely uninterruptible power technologies. This is a recent article, 2020, looking at California, looking at a 35 megawatt microgrid that can interconnect with the grid, but passively separate from the grid to power, this case, an agricultural industrial park for food and food processing. In Puerto Rico, after the hurricanes, we've been doing several of that, which include biogas from the waste, the agricultural waste, as well as solar and wind with battery banks. This is a hospital in Corpus Christi, Texas. And again, it was struck by Harvey, so they designed resilient features in the hospital so they won't get hurt again. And of course, marine resistant systems. That's the other issue. I cannot tell you how many systems are installed in areas that have been flooded or ocean surges. And then what do? They put the energy systems unprotected, and then they get flooded and short out and die. How ridiculous is that? So spend a lot of time getting that understanding. This is one of the systems. It's US made and a New Jersey manufacturer, and this is a solar-driven water purifier and pump. And so you can drop these down in communities to clean the water, and 4,000 gallons per day, and also pump it where you need it to do it. And these are quickly takes an hour to operationalize, and they're very sturdy, and they survive through anything you can throw at them. I have these units and many other companies like these all over the world, and it's crazy we don't have that. This is a company out of Michigan, and this is a marine quality base. The military uses these for forward operating bases. I use these systems for small cell towers and small rural clinics in Africa, for instance, for Ebola. And so these can drop down from a big bed pickup truck. Obviously, you face these south because you want to get the east-west arc of the sun. You open the top out, the solar panels are there, the batteries are there. You have AC and DC outlets. Some of them come with little marine wind turbines on the side. Of course, here's a great fact. I know it's going to shock all of you. Solar only works when it's sunny. Damn. So, but it happens to be that the wind mostly blows at night. So you can basically downsize your battery banks or make sure your batteries are always optimum by blending the two together. How cool is that? So do a lot of those systems. There are tons of companies that are making deployable systems. So here's one that does it off of trailer containers and of all types and has all kinds of functionality. I took this one because of the different functionality and sizing, but that's exactly what you want. But there are about 65 companies that have these sort of hybrid and protected solar battery, small wind, and some other case, sometimes small fuel cell systems, and they're fabulous. And I've used them for years. I want to point out there's also ones that use biomass. This one happens to be in Central America, and you can see a little pile of wood chips there. This is dead tree wood chips, and it's in a gasifier. Again, you're pumping oxygen in a gasifier, and it generates electricity. And these are a little 25 kilowatt units, and they work great. And of course, during emergencies, guess what? You have a lot of knocked down wood. You have houses, you have trees, you have telephone poles. Again, after Katrina, it was horrible. We had so much, the state and local governments wanted to burn it on site. I'm saying, hold it off. Let's get units like these and generate electricity at the same time, rather than just burning it up and creating air quality problems. Again, here's just another unit. This is on a trailer, solar battery system. These are hybrid cell tower technologies. I love them all. And remember, the majority of cell towers, most of the power goes to air condition the electronic equipment, not power the tower. So I use a lot of energy efficiency ways to reduce the air conditioning loads by 2/3, non-mechanical, and then that way I can provide I can provide all the power either on the tower itself or clearly at the base of the tower. This is one out of Japan I've used in Asia, and again, quickly deployable, really tough. Here's another one. Some of the one on the right's used with the military as well. And here you can actually turn the panels to optimize the sun, and it's pretty hardened. These are out of New Mexico. It's actually a Native American-owned company, Sacred Power. And here they're using it for refrigerator units for either vaccines or fish. They're coming in, and they're totally self-powered. And you see a whole bunch of units on a flatbed truck going down to Central America. This one we did with DHS, and this is a container unit up all the way up in Maine, and you're actually looking into Canada from here. It's powering both a cellular and DHS repeater site. We have solar, wind, and batteries. Notice the panels are very steeply shown because gets very high snows, and you want the snow always to fall off the panels. We have it up on stilts, not because of the snow. I hope you're not upset at me here at GMU, but we found that the moose like to have sexual relationships with the boxes and ruin them. So by having them above the moose solves that particular problem. So you do have to worry about animal life. These are little tiny systems with solar panels and battery banks. A lot of these are Wi-Fi enabled and really wonderful too. Here's another company with Solar One out of Massachusetts. Has a little powered solar and a marine quality battery box, and it can also do a water purification if you want it. That's the box behind it.
Sorry for the interruption. We are a bit short on time. Do you think you can wrap this up within one?
I do. I'm almost done.
Great.
Battery banks. Batteries have come down 61% last 5 years, coming down another 21%. All types of batteries, I want to point out. So do not just think everything's lithium ion. It's absolutely not. But this is Tesla's unit, of course, that they lease to households. Sonnen, the biggest battery manufacturer out of Germany. LG from South Korea, of course. Beautiful battery bank. These are my 2 zero energy buildings. In the middle, you see the solar in the front with my giant SpongeBob, notice for the holidays, and a solar in the back, and hard to see the wind turbine in the back, but total self-powered buildings here in Arlington, Virginia. And in my back building, I have included local sensors and controls. We have a renaissance of what's going on. And so these companies I integrated into the building for cyber protection, for battery management, and for load at each circuit breaker. And you can have immense control both for reliability and pricing with these new kinds of apps, sensors, and controls. I just want to point out we have several companies around the world. This is one of them. Out of Seattle, 40 PhD hydrologists, oceanographers, and meteorologists, and supercomputers. They can tell you where solar and wind and water is anywhere on the planet, latitude and longitude, and how high you have to put up the wind turbine. Had a project in Somalia, and they told me it was 85 feet up, wind all the time. The locals said that was nuts. We did it anyway. For the last 2 years, it's been running essentially every day nonstop. So we have a capability we didn't have 7 years ago to precisely predict the where the resource is and the behavior of the resource to optimize the deployable system. And I have, I'm happy to answer any questions here, of course, but you can email me anytime, reports, contacts, questions, and there are no dumb questions. So I'm happy to give resources to anybody. And now I am done. Thank you.
Thank you. Thank you for the informative presentation. Any question from the audience?
I have shocked them all, I'm sure.
It was great. I love that stuff. You've really researched it.
Well, it's really, I do it all the time. And again, happy to give tours to anybody. Again, as long as you wear a mask and we socially distance. I've been doing a lot of them lately, and so far we're all okay, including me.
I'm sorry, I'm in Ann Arbor. I'm Eric. Where are you?
I'm in Arlington, Virginia. So next time you fly into Washington or drive into Washington, come visit me, Eric.
Okay, I do that periodically. Of course, I've done it for the TIDES meetings in the past.
Absolutely. So here's another chance.
Great. So in interest of time, we move on to our panel discussion. So our panelists are Dr. Bandana from Oak Ridge National Lab, Dr. Jess Thornburg from Grapefruit, and of course, Mr. Scott Sklar. I think let me see if I can see, yes. We have Dr. Thornburg, Dr. Carr. Can you hear us?
Yes.
Okay, great. But we cannot see you, but I think we can hear you very clearly. Okay, then. So I would like for our panelists to introduce themselves and tell us about their focus areas within just a few minutes. So we'll start with Dr. Carr.
Hi, everyone. Thanks for having me. Those two presentations have been really great. My research focuses on understanding the resilience of infrastructure in the context of extreme events. So most of the work at Oak Ridge National Lab has been understanding how energy infrastructure could be resilient during an extreme event, but also how best to restore energy outage in case of extreme events from an emergency management perspective.
Great. Dr. Thornburg?
Sure. Thanks for the chance to be here and for the great presentations leading up to this. My focus is heating and cooling. At Gridfruit, we use the data that commercial refrigeration already collects and supplement it with our own data and physics-based models to optimize the energy balance, specifically for commercial buildings to start off with, but it extends to residential buildings and manufacturing, et cetera. But essentially using artificial intelligence to reduce the energy costs, both peak demand and energy efficiency of commercial buildings, starting with food retail.
Okay, and we know Mr. Sklar's background. So I would like to start with this question for our panel. So when it comes to shelter, HVAC, electric power generations, many people are able to see their direct impact on managing emergencies at community and municipal levels. And we have witnessed significant progress in R&D activities, smart building settings, sensors, energy shelter startups, and so on. So in your opinion, what is our current strength in this area that we should build on and make the progress sustainable?
Well, this is Scott Sklar. I think I can start by just saying, and I'm glad we have somebody here who's dealing with refrigerator efficiency. So if you look at loads of buildings, HVAC is usually the biggest load. Refrigeration, frankly, can be a critical load. But the whole idea of sensors and controls to optimize, understand the loads and optimize the loads are pretty astounding. And it's growing exponentially. And I love to hear companies like that because we need it. But after that, once you understand the loads and can maximize and control the loads, then what people like me are called in to do is to make sure that they are operational 100% at all times. And HVAC loads, because they're so huge, sometimes provide some challenges. And I am, let's just say, underwhelmed that how slow we are moving as a society to bring in what I call radical efficiency, as we've done with lighting with LEDs, for instance, or water heating with heat pump water heaters, or waste heat water heaters, or solar water heaters. So we've been dramatic in some parts of the buildings, but some of the biggest loads, which with HVAC and frankly on refrigeration, we need to leapfrog, and it's important for society, and it's important for resiliency, and it's important for greenhouse gas emissions as well.
Yeah, that's a great point. And there's so much data already available, and effective modeling tools. And so I think translating that to the needed regulations and sort of a societal sea change around sort of treating those huge loads as huge and as a burden on the grid. And it's, in many parts of the country, it's a burden at certain times of day. You know, we work with Southern California, and they have, you know, a burden certain times of year. It doesn't show up midday because they have high solar and a lower HVAC load, but then midsummer, they obviously have a huge HVAC load. And so a lot of it's seasonal, a lot of it is regional. And there's so much we can do with, HVAC predominating in residential and most commercial buildings, and then huge refrigeration loads and, you know, food, retail, and packing, processing plants. And we can actually pre-cool both in HVAC and refrigeration when the base load generation is available. You know, when there is solar, hydro already running, we can actually take things a few degrees lower than needed, so that when there's a burden on the grid, they won't have to turn on the coal and natural gas fired plants.
Or they're being destabilized, or just
Exactly.
at the limit. Yeah,
Absolutely.
You
Brownouts.
have a little a zapper part of it, so people will actually pay attention to your data, whether it's the utility or the regulator or the policymaker. When the data says something important, they just get a little zap in their office. What do you think?
I'd love to do that. Yeah, right now it's more at the email alerts and things. But I'd love to go a little further, I think. I'd love to go further. I wish people would pay us to shock them. Yeah. It's a good idea.
Well, thanks.
Dr. Carr?
You might have to repeat the question because my internet dropped.
So I know that you are interested in the next generation of resilience studies. So in this context, I mean, emergency management, with all the advancement we have been witnessing in terms of technology, in terms of models, I mean, AI models, data-driven technologies. So what do you think our strength is right now that we should build on and then move towards sustainability?
With regard to the current situation with emergency management, first of all, making people aware of what the alternate sources of energy, because when the discussion was about with food retailers and the HVAC system, there is an alternate sources, but very often when you talk about sheltering, there is nothing as an alternate source of energy. And you can think about Hurricane Maria as a good example. Hospitals even didn't have any sources of energy, and the solar panel farms were gone. So the first step probably before we build the sustainability is to have an idea and have places for reserve generators and transformers or microgrids. So once we have the alternate source of energy when your power outage is going on, then people can use that and the recovery and response process can continue simultaneously. But currently there is nothing in place when it comes to storage generators. Even when that discussion we had with regard to the solar panels that Scott was talking about, yes, we have solar panels, but rarely we talk about the storage devices. So I think that would be the first step, and have a buy-in from the local communities, because you cannot have a storage device unless there is a buy-in, as well as the emergency management agencies have to fund it. So somebody has to take responsibility for the financial aspect of it as well. So they go hand in hand. And most of the shelters that are being used for emergency response, they need to be located in a place where it is easy accessibility to get that alternate source of energy, be it from storage devices or from some other sources. So we need to go back to the drawing board and address the geo-design component of it and build from there. That's just my 2 cents.
Yeah, I agree with Dr. Carr on that, but I want to point out we have I'd say about 500 megawatts going in of battery banks now into hospitals around the country, and so we're starting to see that as even the portal for traditional diesel generators. Of course, you have a lot of power quality problems, surges, sags, and transients, which ruin the digital equipment in the hospitals from the generators. So, you know, you're bringing battery banks to solve that problem and help your legacy systems, your backup generator systems work more reliably, and then bring in the solar or the wind. But I'm also seeing a lot of waste heat systems. Hospitals generate huge amounts of waste heat that you can not only recycle into the heating or cooling of the building, but also turn into electricity. So I totally agree with Dr. Carr. We need to rethink this a little bit, see what commercially available equipment and sensors and controls and apps are out there to optimize it, but start bringing it in real time. In many cases can be funded by the private sector once the planning is done. The planning function is really important.
Good point. Eric and Jonathan, just feel free to jump in if you would like to add any points. So Eric, you present the shelter side of things, and feel free if you have anything to add. If not, I have another question to ask. Great.
The one thing, the pre-cooling of is a brilliant storage idea. They were doing it, I think, in the Netherlands by at night setting down their cold storage facilities, and then during the day turning them up, and so then they weren't using using power. So there's so many ways of storing energy and reducing our loads that we don't even think about. Like you were saying, Scott, hospitals. I live near the University of Michigan hospital, and the amount of, you can almost see the energy shimmering off the buildings. And you can hear it from in the air handlers for sure.
Yeah.
Good point. Good point. Well, I just mentioned about the AI technologies. So the question coming to my mind is that if we use our imagination, okay, what does the next generation of shelter, heating, cooling, and energy systems look like?
Well, that's a great question. Well, I'm sorry to jump in, but I guess I will. We see so many innovations coming in. We see smarter insulation, different coatings and barriers in building envelopes to reflect heat out during the summer and take it in during the winter. We see a lot of passive heating and cooling systems. We're seeing a lot of, again, sensors and controls for thermostats, speeds of ducts, speeds of vent fans to move air around. With COVID, we're actually increasing airflow in buildings so you don't have dead air spaces, because that could be dangerous in the future. And then we see all these different great innovations of different equipment and lighting. And I think what's really going to change the game are the companies and the builders that know how to integrate all of that way more optimally. And so it's not piecemeal. When I get called into a lot of building projects, I just see these piecemeal things, and they're not elegantly integrated. And so, and part of that is the industries themselves need to understand they're interacting with other technologies. And so they actually may need to talk to other industries and not just rely on the engineers and the architects to work around their interface and design. So I'm seeing movement in that direction in certain areas of the country and certain parts of the world, but that needs to be accelerated. And part of that can be, you know, government funding and working with the DOE labs like Oak Ridge and NREL and Lawrence Berkeley and Lawrence Livermore. But a lot of it will also have to be driven by state and local governments that deal with building codes, so that they're really encouraging that. And it's going to need some creativity sort of all along the applications side of this, so we accelerate this integration. That's my personal view.
I have a few points to add to Scott, and thanks for jumping in, Scott. I think other than the planning aspect of it, we need to understand the extra energy, what Scott was saying. When exactly we need to optimize the energy supply and the demand, because currently that doesn't seem to be happening because of so many utility companies. Everybody has their own territory and they need to understand it. And within COVID-19 and the wildfires, we have seen a lot of disruption with power outage. So that is one thing. So we need to have a buy-in from the utility companies, but also the local agencies, because the planning and the zoning is local agencies, but the utilities are private entities. So the public-private partnership to understand the supply and demand and how to optimize the production of energy and which energy sources should be used alternatively, that has to happen. So although innovations are there, I don't think innovations are happening at that scale. They need to go down to that scale. The second is the innovations, and Scott said, yeah, this is happening in a piecemeal manner, which means we are providing a lot of models and data that are not very, they are not standardized, which makes it very difficult for different companies to use the innovations and the technologies. When you go down to the computing side of things, that requires a lot of overhead. Make them talk to each other, like the SCADA systems. They generate so much of data, but very rarely we are doing anything with it. So we need to understand the data formatting aspect of it before they get embedded in it. Then the third point I would suggest, we generally don't talk about it. Most of this, the sensors deployment, has the moment we go into the AI territory, the ethics and the privacy components. So if we want the buy-in from everybody, we need to understand how that privacy aspect is going to be maintained, as well as we are going to be cognizant of the fact that there might be hacking also. So what happens if we have similar situations? Like Oak Ridge has some smart buildings where they do the study for sensor deployment and the analytics, but this question pops up all the time. How are we going to address the privacy and the ethics? And if hacking happens, then what are the alternatives? So AI is a good solution, but unless we understand the implication and have an understanding for the local public, then it is very difficult to have these integrated, because we have planning, then we have buildings. So they are at different scales. Then we have technology, then we have legal issues. So we have so many pieces to it. It seems like both public and private sectors, they need to sit down, have a discussion to understand the different components of it. Otherwise, we are going to see this piecemeal approach where different companies are coming up with their solutions, but we are not going to get a comprehensive implementation of everything to create a smart solution for everything. That's just my take on it.
Yeah, I would jump on that and say the piecemeal haphazard approach is definitely creating cross incentives that limit uptake of these great technologies which we have available. So I transitioned from academia to founding this startup about 2 years ago, and was kind of shocked at the benefits and the cost savings we can provide in energy, but then how these food retail stores in many cases are not incentivized by that. You know, most verticals in a typical food chain, even if they see the dollar savings, once they hear it's in energy, they say, oh, well, that's an assumed cost on our balance sheet. You really have to get to the CFO or the CEO for them to pay attention in many cases. And so I think, yeah, the utility buy-in and messaging to incentivize this would go a long way in kind of unifying the sectors around energy savings and emissions reduction.
Great points. Eric, do you have anything to add?
Well, sure. If I could segue into my little presentation on shelter, we do. I'm supposed to be on around 2ish, and we do a disaster relief for temporary shelter in the world of the homeless. It's called Transitional Shelter, and we try to integrate into our buildings small solar units, small waste treatment, water treatment. It's the same model that's used by Shelter Box, except we have a hard-walled structure. It's called the DecaDome because it's got 10 sides. It's a geometric structure, and I suppose is it okay if I start sharing my screen?
Absolutely, you can go ahead and share your screen.
Okay, and in the spirit of TIDES, I'm going to also talk about some other shelters that are out there besides ours that are making some inroads into the problem. Okay, let's see, screen share. Let's see what it does here. Hello, please share. So there we go. Okay. Okay, let's just start with this. Might as well. Hello.
Okay.
Let's see if it comes up. Okay.
Yes, we can see your screen.
Okay, so you can see that logo.
Yes.
DecaDome. Let's see if it all expands. That's my little PowerPoint. I think that's it. Let's see if I can get it to load. Trying to see what this is. Well, we'll find out when I start it. Oh, this is actually an assembly video. Okay, so your home, I'm sorry, your home's been damaged by an earthquake. You don't want to go inside, but you don't want to leave the lot. So you can put one of these guys up in your front yard. Okay, can everybody see the assembly?
Yes.
Yes, that's good.
Good. Yeah, so they're 10 walls, 10 roof panels. They're all identical. This one's got a built-in floor. You always put a vapor barrier on the bottom. The panels can vary depending on where you are, and the window sizes can vary. One of the big, there's a lot of advantages of this thing over certain other kinds of structures is that their structural strength is amazing, and their wind resistance is also pretty unbelievable. And I've got some videos too. So the actual assembly was about an hour. Took this with an iPhone. We can do various kinds of skylights, panels, roof membranes, depending on where you are. If you're in okay, I'll get rid of that. Stop share. Okay, so that's and that's the basis of our whole. Let's see if I can find the rest of the stuff here. Our system, let's try this. There we go. I apologize profusely. So basically the theme of our whole work over the last actually 40 years that we've been playing around with this idea has been that these are hard-walled shelters that are easy to scale up, but also are designed for human habitation. Not just ease of assembly, but they are easy to assemble, and they're strong and all sorts of other good things. See if I can actually get my whirling ball of death to stop here. It won't go to, let's see if it'll let me go to slide 2, and it's completely not helping me out here. I'll try, I am screen sharing. I'm gonna stop it. Now I'm gonna start it again. For some reason, I'm just getting as I say, the whirling ball of death. It won't let me go to the next slide. Let's try something else. I really apologize. I tried all this out before the meeting, and it all worked just fine, of course.
Maybe you can just talk about them and hopefully.
Yes, I can do that. And I'm just going to, here we go. Okay, I will talk about them. Well, you can see from this one slide, if you are seeing that one slide, that this is what the buildings look like from on top. And I'm really sorry that I wasn't able to, now that my computer is just completely crashing here, at least it's still semi-functioning, but the shape has vertical walls, unlike the Bucky Fuller geodesic domes. So you can use a standard door, a standard window, and you can use standard panels of almost any kind with our connectors. You can go to DecaDome.com and see basically all of the details. The whirling ball of death is still there. No, I thought it stopped for a minute. So we've been using a variety of kinds of panels. Our standard panel is an aluminum skin foam core panel that is used very commonly for insulated garage doors, for recreational vehicles, for sunrooms in houses. So it's got a code rating. And it's a very versatile panel. We've had buildings that have lasted for 25 years made of that panel with no real degradation of the panel. And what I was really hoping to show today was some film that we took in wind tunnel testing, because it's fascinating. We took this to 2 different wind tunnels, the University of Michigan Engineering School wind tunnel and the Ford Motor Company wind tunnel in Allen Park outside of Dearborn. And we got these models up to 100 miles an hour at U of M and 86 miles an hour at Ford Motor. And there was absolutely no movement, no damage, nothing. And we did, interestingly, smoke tests as well, that's what's interesting to see, because the smoke flows around them like they were cylinders, is how they behave. In high winds, there's no eaves or overhangs to catch the wind or to catch fire debris or whatever, although they're not going to survive a giant fire like California's been going through. But I don't know why things are moving so slowly, but looked like it was starting to load. There we are.
Yes.
So these are just some of the different applications that we've used them in. You get a better idea of what I'm talking about, the shape. And the center one we built in La Boule, Haiti, on a mountainside. And that was for an auxiliary classroom for the YMCA of Haiti. On the left was just something we put up in Ann Arbor for an event, and on the right as well. But we've also, let's see if we can find another. Okay, so this is the one going up in La Boule. This was a 1-inch thick panel, and you of course build them for insulation in the north. So we use at least a 2-inch foam core panel in northern climates, but in southern climates, of course, it's ventilation. And of course, a white skin means that you're reflecting most everything that hits it. That's the secret to keeping these things cool. They do require a membrane over the top to keep them dry and to seal them up. But all the panels, as you can see, are identical. The connectors, which we extrude, are all identical. So there's identity of parts, which helps. So we build a 3-foot a unit with a 3-foot panel, which makes basically a 75 to 80 square foot building, but it's got a lot of headroom, so it's got a lot of volume and they stay pretty cool. They ventilate very well. Our standard is a 4-foot panel that makes 100. He says 157. It's actually about 125 square feet. Might be 100. Yeah, it's about 125 square feet. And that's a good size unit because it's got that high ceiling. And then let's go on to the next one. I don't know why it's been taking so long to load, but there it is. So this shows you the different models. The one on the left is a tropical model because it's got windows. It'll have windows in every panel. We put these panels on a CNC machine, so you can cut a door and window or any shape you want in about a minute. It's pretty incredible. There's our connector. They're extruded, which is the cheapest form of plastics manufacture. It's like squeezing toothpaste out of a tube. This is another thing about these units is these panels are all off the shelf effectively, because they build these kind of panels all over the country. So, and they also have extrusion plants, PVC in this case, extrusion plants all over the country. So you can just crank these out, and this is a process which could be transplanted anywhere. Our panel plant is in Holland, Michigan, the company we use. And on the right, you can see that's a average Michigan snow load, actually a little above average, but you can see that building is 25 years old and is still standing.
There is 1 more minute, if you can wrap up.
Sounds good. Here is the last, this is the features of the units also are that all the components are hand portable. You can ship them easily. We ship these units to Haiti, one of them to an orphanage in Haiti. Actually 2 units that are still in use there. So they can be easily assembled and disassembled, and they work. And they're easy to both manufacture and assemble and disassemble. So I've repeated myself. I apologize for the technical glitches. Thank you for your patience.
Thank you for being resilient. So that's the real example of being resilient when something goes wrong, and then you have an alternative solution. So just your contact information is on the website. So if anyone has any question, can reach out to you. In interest of time, I move on to our last presentation, which is a video prepared by Gridfruit team. So I need you to stop sharing so I can share my screen and then play the video. Great. Okay, this one.
Hi, I'm Jesse Thornburg with Gridfruit. We're excited to be partnered with Southern California Edison and EPRI for Incubate Energy Labs 2020. At Gridfruit, we put energy data to work to reduce the electricity bills for food stores, and at the same time reducing emissions and peak demand for the grid.
Gridfruit technology provides SCE with the opportunity to address high evening peak loads and reducing greenhouse gas emissions, while providing underserved convenience stores and potentially even supermarket stores with real cost reductions.
The challenge we are tackling at Gridfruit for Incubate Energy Labs is to reduce the power demand spikes that stem from refrigeration defrost. Oftentimes, these defrost cycles occur at adverse times for both the store and the utility that serves the convenience store's electricity needs.
Through this project, we demonstrated that we can save the convenience stores of Southern California Edison $13.5 million per year, and we can provide $24 million per year of savings across all of California.
Due to the COVID-19 pandemic, we transitioned our project to a simulation platform. Through these simulations, Gridfruit gained valuable insights into how to tune our optimization algorithm across various climate zones, as well as a stronger understanding of how utility pricing structures connect to both reducing cost for the end user and reducing power demand for the utility.
The results of our experiments that we did using the modeling tools that Gridfruit has showed a bill savings of approximately 7.5% for the customers, a peak reduction of 4.5%, and greenhouse gas reduction of 4.7%.
And I would say participating in the Incubate Energy has been really valuable for us. We got connected with different utilities and we received valuable feedback.
Hi, everybody. I'm Annie Haas. I am the program co-lead for Incubate Energy Labs, and it's my pleasure to introduce to you today Team Gridfruit. We'll get right to it, and I'd like to turn the mic over to Jesse Thornburg. And Jesse, tell us who you are, about Gridfruit, and what it is you do.
Thanks, Annie. I'm Jesse Thornburg, co-founder of Gridfruit. We're really excited to be partnering with Southern California Edison and EPRI for Incubate Energy Labs 2020. My team formed Gridfruit from energy technology we developed at MIT and Carnegie Mellon University. We reduce energy bills for food businesses by optimizing how their refrigeration runs. We do this by building digital twins of the food businesses, and then we use artificial intelligence with refrigeration data, so our software learns and accommodates the needs of each food business. This in turn helps the grid by reducing peak demand and greenhouse gas emissions.
Excellent. Thank you so much, Jesse. Appreciate that. We're going to pivot next to Edwin Hornquist. And Edwin, you want to introduce yourself, please, and talk about why this project, why GridFruit, and why it's important to you at SCE.
My name is Edwin Hornquist. I'm with Southern California Edison. I oversee the Emerging Technologies program at Edison and statewide. The fundamental reason why we were attracted to this project initially, or this technology, was the fact that we was focusing on an important area for the utility, area where we are trying to manage our evening peak. We're trying to manage our 4 to 9 peak, but also we want to do it smartly by providing benefits to our customers. And the fundamental question that GridFruit brought to us was, we can do this and we can do it with no impact to the customer, and bringing value to both to you and to the customer. And not only that, we're focusing on convenience stores initially as part of this pilot demonstration that essentially reduces the risk for us on subsequent phases of this project. And by focusing on an underserved market, we felt that addressing also program needs. So not only it presented an opportunity for this market that had been underserved for many years, but also the potential for a growth beyond its current application. Thank you.
Thanks so much, Edwin. So we'll turn it over to Ami Amarnath from EPRI now. So Ami, can you introduce yourself and then talk a little bit about what we did in this demonstration and what the results were?
Thank you, Annie. Again, my name is Ami Amarnath. I'm a senior technical executive in the customer solutions group at EPRI. I manage energy efficiency, demand response, and related areas of research. So this whole idea, like Edwin mentioned, is the reduction of peak demand. And one of the underserved markets is convenience stores, stores like 7-Eleven. So the whole idea is to use this artificial intelligence platform and modeling technology that Jesse and his team has developed at GridFruit, and explore this possibility of testing it in several stores in Southern California and in California in general. Because of COVID, we went forward with doing a simulation of this whole area using their artificial intelligence platform. And like Edwin mentioned, there were 3 areas, that is of importance. One is reduction in bills for the customer, which is one of the most important areas. Second is peak reduction for the utility. And thirdly, related to greenhouse gas reduction. The modeling exercise that we did showed that for the whole state of California, there are over 12,000 of these small convenience stores. We can see approximately 7.5% reduction in bill savings for the customers, approximately 4.5% of peak reduction, and 4.7% of greenhouse gas reduction. So this is a wonderful exercise. For Southern California Edison service territory, the results are more or less similar, and this is what the results of the project were. Thank you, Annie.
Excellent, Ami. Thank you so much. I'd like to shift it back to Edwin. Edwin, so what do these results mean for Southern California Edison, and what's next?
Yeah, so as Ami mentioned, the potential is pretty large in focusing on an underserved part of our customer base. So the savings are real. Savings are potentially scalable to other similar end uses and that have refrigeration type equipment, which is very exciting. So this alone represents already a pretty interesting opportunity, very impactful opportunity once at scale, and it does deliver savings to the consumer. So what we want to see next is really validating these outcomes in a way in situ through some sort of a field demonstration. And the idea is that by doing this, we'll be able to really understand any other barriers that potentially could crop up in the course of implementing these solutions. There is a roadmap that Jesse may talk about a little bit later, perhaps, but it talks about how some of these less challenging and easier implementation pathways are. But we're excited about that we were able to validate with fairly good degree of certainty where the opportunities are and bring value this way. And we're excited for it and partnering with them and continuing to understand this potential solution better.
Edwin. Jesse, could you talk a little bit more about what this means for GridFruit?
Definitely. Yeah, through this project, we were able to show the benefits we provide at a new scale. As Ami mentioned, that's basically looking at effects in the convenience stores across SoCal Edison and across the whole state of California. And the reductions he mentioned translate to $13.5 million in annual savings for Edison's convenience stores and $24 million in annual savings across California. So we have been actually expanding on those results in the digital twins. Now we're modeling larger stores to even throw that into the aggregation and look at the results, partnering the control in larger stores with the convenience stores. Thankfully, Edwin and his team are introducing us to food stores for that in situ field testing. And we're also in advanced talks with several utilities in the Southeast who are interested in these results and the demand reduction and emissions reductions that we're demonstrating for Southern California Edison.
Great, thank you. Ami, in 30 seconds, what do these results mean for EPRI and what's next?
I think, thank you, Amy. I think Edwin and Jesse have expanded on this. And essentially, it's really to validate the technology in doing some real live testing in convenience stores. That's item number one. Expanding it around the country, doing a collaborative test with a bunch of other utilities. And finally, expanding it beyond just the peak reduction in the defrost cycles, perhaps looking at the HVAC loads, optimization, and things of that nature. So this is a very exciting project, and we are excited to move forward.
Thank you. Very interactive video, and thank you for providing us with this recording, Jess. Well, Jess is online. Do you have any question for him? Okay, great. So we are right on time. I would like to thank you again for joining this track. We had a great discussion, and I hope that you enjoyed the rest of your day, and we'll be in touch. Thank you.